Good morning. In this lecture, I will be explaining introduction to cycloconverter. So, cycloconverter is a power electronics device that converts AC signal with fixed frequency and fixed voltage to a AC signal with variable frequency and variable voltage. This type of converters mainly used in low frequency and variable speed applications than the industrial motor drives and the marine systems. Some key features of cycloconverter. So the direct AC to AC conversion. So what is the meaning of that direct AC to AC conversion? So it converts that AC to output AC without intermediate DC stage. If we use inverter and rectifier for converting AC to AC like this, suppose AC, then there is a one conversion. So by using rectifier we are getting DC. So again this DC is converting by using inverter and we are getting AC. So in between these AC to AC conversions, so there is a one intermediate DC stage. So basically in case of that cycloconverter, so it is just skipping this DC stage. So it's directly converting this AC to AC. So these are the this is the one key features of this cycloconverter. Then step down frequency conversions means it reduces that higher input frequency to a lower output frequency for specific applications. Then bidirectional power flow. So means bidirectional power flow means in case of that bidirectional power flow, the power can flow from source to load and load to source. So what is the application? So in case of that, if power is flowing from load to source, so in that case, so that can be used as a regenerative braking applications. So this load to source power flow is beneficial for regenerative braking applications. Then thyristor based switching. So means for this cycloconverters, so basically we are using different semiconductor switches like thyristors. By these thyristor based switchings, the cycloconverter effectively or efficiently managing that high power. Okay, now we'll see the different types of cycloconverter. So based on these three different stages, we can classify these cycloconverters. So first is step down and step up cycloconverter. So basically the step down cycloconverter that reduces the frequency, and if it is a step up cycloconverter, it is step up that frequency, means increases that frequency and the output. Now based on that output phases configurations, by using these also we can classify these cycloconverters into three types: that single phase to single phase, then three phase to single phase, and then three phase to three phase. These three configuration exists. Then based on that control technique, one is that blocking mode, another one is the circulating current type. So this blocking mode uses the thyristor to block waveform segments, and the circulating current type uses this positive and the negative converter groups. Then these are the some advantages of cycloconverter. So that precise speed controls, by adjusting the output frequency or by varying the output frequency, it offers very smooth speed control of a motor. Then bidirectional power flow. So this handles power flow in the both the direction. So that is if that power is flow from load to source, so that is one advantage, as it is ideal for that regenerative braking applications. Then high efficiency at low frequencies, means it's maintaining efficiency in low frequency AC applications without intermediate DC conversion. So if we are keeping that DC link, so in that case we are reducing that devices. So if we are reducing that some devices, which will increase the efficiency of that converters. So then that some limitations is also exist in case of that cycloconverters. So what are the limitations? That frequency means it's basically only it reduce the frequency. So this is the one purpose of this cycloconverter. So generally cannot increase the input frequency. Then that complex control requirements means, so for this frequency, for varying the frequency, so we are using in case of the in the cycloconverter, complex control requirements. So what is the meaning of that? In cycloconverters, it uses different semiconductor switches for varying the frequencies, whether it is step up or step down. So there are so many semiconductor device, it needs to turn on and turn off precisely for getting that output frequency for the required output frequencies. Then that harmonic distortion. So it's generate distortion, especially at higher output frequencies. Then the low power factor can result in less efficient power uses. So these are the some limitations of cycloconverters. Then that applications, so different types of applications are there in these type of converters, that cycloconverter. So industrial applications, mainly that steel mills. So in case of that steel mills, for that metal shipping, that variable, that control, speed control is needed. So this, by varying this frequency, you can control the speed of a motor for shaping the metals in the steel mills. Then that cement industry, for that crushers, that so even for that crushers, that variable speed and that motor driving is needed. Okay, in the cement industry, that variable speed of that large motor is required for the crushers. Then mining operations, so these drives large waste and conveyor belts with necessary torque control. So these are the industrial applications of cycloconverters. Then we will see some transportation applications where the cycloconverters mainly use that marine propulsion. So control large motors for ships propulsion, then optimizing speed and that fuel efficiency. So there, so we are using cycloconverters. Then the railway tractions, it enables smooth acceleration and deceleration and in electric locomotives. Then that aerospace systems provides frequency conversion for specialized equipments in aircraft and military vehicles. So these are some application in transportation, and here we will see some energy and that power applications of cycloconverters. Then variable frequency power generations means it's adjust. So by using these cycloconverters, we can easily adjust the frequency for grid synchronization in hydroelectric power plants. Then the renewable energy systems means it converts variable frequency output of wind turbines to grid compatible frequency. Then that synchronous motor drives provides accurate speed and torque control for large industrial motors. So these are the different applications of cycloconverter, and this is the basically this is the introduction of cycloconverter. What is the key features, advantage, limitations, and applications of cycloconverter? In the upcoming lecture, I will be explaining different types of cycloconverter, like what is step up cycloconverter, step down cycloconverter, then bridge type, midpoint type, then single phase to single phase, then three phase to single phase, three phase to three phase cycloconverters. Thank you.